So the next one is consecutive transformations, and it seems very basic, but I actually think you can spend the vacation just a day or two on this. So the idea is that you're going to be given a function, and maybe it's a piecewise function. We're not really sure what the function is, but you're going to be told it has a transformation. They're going to say, here's the new transformation, like g of x is equal to negative 2f of 3x minus 5 plus 7. And they're going to say, well, IB is going to say, describe the transformations. The book, Cambridge, is actually asking you to sketch this. I'm not going to have you do that, but actually, in a following video on the GDC, we're going to come up with something interesting. But what's going on here? Where do we start? Well, we have all the transformations here. We have reflections, shifts, and stretches and stuff. So how do we interpret this? Well, we're going to start from inside here. We're going to look at the 3x minus first. Look at the 3x minus 5. What's going on here? Well, the first thing is we start with f of x. What we've done is we've shifted it 5 to the right. So it's a shift, and it's a horizontal shift, 5 to the right. Right? And then the next thing we see is we replace the x with the 3x. So it's 3x minus 5. And what is this? This is a horizontal stretch by a factor of 1/3. Please remember that. The horizontal stretch is the reciprocal of the number in front of the x. It's a little counterintuitive to me, but this should be fine. Well, what's the next thing that's going on here? The next thing that's going on here is, so we have, let's see. What's the next thing? We have 2 times f of 3x minus 5. This is what? This is a vertical stretch by a factor of 2, right? Now, remember, with the vertical stretch, it keeps the number. What's the next thing? Well, we have that negative 2 f of 3x minus 5. That negative, that's the reflection through the x-axis. And then last but not least, we have negative 2f of 3x minus 5 plus the 7. This is a vertical shift. I call it a V-shift. Do not use the word move. Call it a shift. Yeah, call it a shift. And then 7 up. And that's what you're going to be doing. So you're going to be giving examples, and that's the idea. Once again, this is the most difficult part, but everything else makes sense. The other thing is, don't use the word move. It moves it or goes there. Use the word shift, up, down, left, right. And then we'll be working on, I'm going to show you something in the video that I thought it was interesting. Okay, so we're looking at, so we just had the video presentation of the transformations, and I'm looking at the problems in the book, and what always made me nervous is they ask you to sketch the new graph after a set of transformations, and IB doesn't ask you to do that, but they ask you to describe the way we did. But then I looked at these and I said, wait a minute, we can actually have some fun with this. This can be interesting. So I looked at I went in the book. And I looked at page 168, and I saw they said below is the graph, and they said sketch the corresponding graph for y equals 3 minus 2f of 2x plus 1. And they asked you this a couple of times. For question number 2 on page 180, they gave you 2 graphs that are clearly not functions that we know, and they asked you to sketch transformations. And the same thing here on questions 3 and 4. And I realized, wait a minute, this could be interesting. We can actually construct these. So let's go to this example here. Below is the graph of f of x. And I said, wait a minute, that is a piecewise function. We can construct this ourselves. So the first thing I noticed is that this first segment from -5 to 0 is y equals 2. So I went to my graphing calculator. I did tab, next to the 9, and then you're going to do, because there's more than 3 pieces, you're going to click on this piecewise for 3, and they're going to ask you how many pieces, and you're going to say 4. We want 4 pieces. So as I said, the first piece, let's just go back for a second. The first piece is from -5 to 0, and it's y equals 2. So 2, tab, -5 less than x less than 0. Okay, let's go to the next part. Well, the next part is a line. It's starting at 2, so that's our y-intercept, right? And it's decreasing, and it's going down 3 to the right 2. Well, that's 3x over 2. That's the equation of our line. And that is from, let's go back to the graph, and that is from 0 to 2. Let's see, that's from 0, x, 2. Next line. The next line is a line. It's starting at 2, -1, and it's going up to 3, 1, 2, 3, 4. And this is basically just find the equation of a line between 2 points. It turns out, and you can fit, once again, you can see this point is 2, -1, and the next point is 3, 4. You can, I'm assuming you know how to find the equation of a line given 2 points. It turns out the equation of that line is 5x minus 11. 5x minus 11, and we said that was from 2 to 3. And then the last part is very straightforward. It's from let's see, 3 to 5. This is 4. So this is 4 from 3x to 5. And let's graph this. Nice. We have this. This is great. We figured it out how to make that picture in the book. Well, we don't need to recreate all this. The idea is they've given us a transformation. If I move it over, we see it's 3 minus 2 times f times 2x plus 1. And so what I did was in the graphing calculator was, if you look at tab number 2, I already completed this. I did 3 minus 2 times f1, 2x plus 1. And you can fool around with it. And what you can follow the book, or you just go to the final answer. Before we do that, let's see what's going on here. So we expect it to go 1 to the left. We expect a horizontal stretch with a factor of 1/2, right? And actually, you know what? We can do that. We can do that ourselves. So let's take this out. Let's take all this out. First thing is 1 to the left. Nice. What's the next thing we do? Of horizontal stretch by a factor of 1/2. What's next? Well, we reflect it over the, we have that negative there. Let's go tab, up. There's a negative in there. Well, actually, it's time 2, so it's a vertical stretch by a factor of 2. Next, there's that minus sign. Let's put that reflection in there, tab, up. Let's get in there, the negative. So it should be a reflection over the x-axis. And then the last, we have that plus 3 in the beginning. Let's see, tab, up. Let's put that 3 in there. So instead of -2, I'm going to see 3 minus 2. Nice. And that's where we get this from. So the question is, how do we make these other pictures? Well, if we go to question number 2, right here, we can see that from -6 to 4, that's y equals 2. There's a line that's decreasing from -4 to -2. That's a line that's decreasing. You can find the equation of that line. And there's a line that's increasing from -2 to 6. You can find the equation of that line. The next one, this is a little difficult. It's very advanced. You're not going to be able to do this. Just describe the transformations. And then these two, this is kind of interesting. You actually can do these things. Let's think about this one. When they say number 4, let's see. Oh, no. For 3, no. They involve 3. Is it all of these? Oh, No, that's number 2. And then for number 3 and 4, the question is, what are these two graphs? Well, let's think about f for a second. We just did with the oblique asymptotes. We know that f has 2 zeros of 1 and -1, and we know it has a vertical asymptote of 0. So I think that is x squared minus 1 divided by x. And the second graph we know is a cubic. We know that we can start off by saying x plus 2 times x minus 1 times x minus 2, but we know there's that a in front, but we also know there's a y asymptote, a y-intercept of 4, so you can easily construct the cubic. If you want to try to construct the cubic, go for it. I think it's kind of interesting. If not, just describe the transformations. And that's it. That's it. Excellent. And I'm going to put one more video up. Thank you. So I just want to summarize what we did before, which is simply what all these variables are. So we have a, f of bx minus c, plus the d. Let's just start from the inside. The first thing is we have the horizontal shift of c. Then we have a horizontal stretch with a factor of 1 over b. Then we have a vertical stretch with a factor of a, right? If a is negative, we're going to have a reflection over the x-axis, and last we're going to have a vertical shift of d. One last thing, you might see, a translation with a vector of, let's just use these letters of c and d. This is telling us c, this is the horizontal shift, and this is the vertical shift. We're going to see this with a vectors unit, so this is x and y. And that's basically it. I think that's everything I want to say. Yes. Yeah. Good. Oh, also, I'm sorry, one last thing. Another thing to discuss is the order that you do these transformations. You learn a word about the word commutative. And the question is, does order matter the way I do things? If I shift and then stretch, does it matter if I stretch and then shift? Here's the thing. Transformations are not always commutative. Sometimes you can switch the order and it doesn't matter. Other times it does. Well, what's the rule behind that? If you're doing an X transformation and then a Y transformation, the order doesn't matter. So if I do a horizontal shift and then do a vertical stretch, it doesn't matter if I first do a vertical shift for stretch and then a horizontal shift. But if I'm doing a horizontal shift and then a horizontal stretch, it does matter of the order. So if both transformations are X transformations, then order matters. But if the transformations are like X then Y, then order does not matter. Order does not matter. And so that's something you'll think about. And you could try that on your own. Do a vertical shift and then do a vertical shift and then a reflection over the x-axis versus taking that point, first reflecting it, and then shifting it. You can clearly see that they're not going to be the same point versus if I move something 2 to the right and then 3 up versus going 3 up and 2 to the right. It doesn't matter. Or, shifting up 1. Let's say let's say I shift 2 to the right, but then multiply the vertical by 5, versus multiplying the vertical by 5 and then just moving it 2 to the right. It's going to take me to the same place. So once again, if both of your transformations are x transformations, or both of them are y transformations, x transformations or y transformations, order matters. But if you're doing an x transformation and then a y transformation, it doesn't matter. Good.